So section 4.9, we are graphing inequalities. These are the rules from inequalities that we've been using forever, okay, since we first introduced inequalities. Decide whether it's a dashed or a solid line, and then use a test point to decide which part of your graph to shade. So the first example I'd like to do is actually not the first example on your notes. That one deals with fractions, and not that we can't do fractions. Fractions are fine, they're part of life. But I want to get as simple a problem as possible so that you guys see the process, okay? So let's go ahead and take a look at the second example. So taking a look at y is greater than x squared minus 2. Well, just like the one we did in the homework a second ago, is this written in standard form or vertex form? You could say it's in vertex form.
It's in both.
It's in both, yeah. Or you could say it's standard form. Okay, it's actually written in both forms. If you think it's vertex form, then you're thinking y equals x plus 0 quantity squared minus 2. That's fine. If you're thinking standard form, then you're thinking y equals x squared plus 0x minus 2, which is also fine. It'll give you the same information either way. Okay? Now, something else to please remember is that when we're graphing inequalities, we treat them like equations throughout the entire process until the very end. Okay? So that's why right here I'm writing these with equal signs. Okay? So, where's our vertex here? 0, negative 2. So that means our axis of symmetry is x equals 0, or just the y-axis. And our vertex is at 0, negative 2. So we need 2 points on one side to graph this. So let's pick x values of what? 1 and 2. Yep. All right, so we plug those back in. We have y equals 1 squared minus 2. Well, 1 squared is 1. 1 minus 2 is what? Negative 1. And we have y equals 2 squared minus 2. 2 squared is 4. 4 minus 2? 2. So we have a point at 1, negative 1, and at 2, 2. And again, just as we did last week, the 2 points we have on the right side, we need to reflect those to the left side of our axis of symmetry. Well, now we're ready to graph, and we got to decide, are we graphing this with a solid or a dashed line? This is where that inequality now comes into play. Solid or dashed? It is dashed, because it's not or equal to. All right, so it looks something like that. And we need to decide where to shade it. So we need a test point. Yep, 0, 0 is always a good test point. The only time you can't use it is when it's actually on your boundary line. Well, it's not in this one. It's actually sitting inside our parabola. So plugging 0, 0 into the inequality, we have 0 is greater than 0 squared minus 2. Well, 0 squared is just 0. 0 minus 2 is negative 2. Is that true or false? That is true. So remember then, the inside of this parabola is the true portion. The outside of the parabola is the false portion. And you always shade the true part of your graph.
Mr. Bobier?
Yes?
When we draw the parabola, do you want us to make it go all the way to the top?
Yes. You need to fill your graph.
Okay.
Yes, ma'am?
The red thing that you crossed out, was that a 0?
Mm-hmm. It's 0 squared. On the back side of your notes, we have this example. So, y is less than or equal to negative x squared minus 4x plus 3. Well, again, to graph this, we need to find our vertex. Okay, so we're going to have to use x equals negative b over 2a, because this one is definitely in standard form, right? It can't be thought of as being in vertex form. So negative b, so that means we have negative 4 over 2 times negative 1. So that gives us an x value of negative 2. We plug that back in. So we have negative x squared minus 4 times x plus 3. We're plugging in negative 2. Remember your order of operations. We need to do the exponents first. So negative 2 squared is positive 4, but then there's that negative sitting out in front. So we have negative 4 plus 8 plus 3. So what's our y value? Yeah, 7. That tells us our vertex is at negative 2, 7. So our axis of symmetry is that vertical line, x equals negative 2. And let's see, negative 2, 7 sits right there. Now, because we're in standard form, we can find our y-intercept as well. Our last example, we didn't care about the y-intercept because our vertex fell on the y-axis. Therefore, our vertex was the y-intercept. That doesn't help us graph. But here, our vertex is not the y-intercept. So the y-intercept is going to give us another point that we can use. The y-intercept always comes from the constant term in standard form. So we have 0, 3 as our y-intercept. Okay. We need one more point to be able to graph this. Notice that we have a point with an x-coordinate of negative 2. We have a point with the x-coordinate of 0. Split the difference. Go with an x-coordinate of negative 1. So when x is negative 1, y equals negative 1 squared minus 4 times negative 1 plus 3. Gives us negative 1 plus 5 plus 3.
Negative 1.
Thank you. Yes, it is negative. I said negative 1, but I wrote positive 1, didn't I? It should be a negative 1 because you have negative 1 squared, which is positive 1, but then we have that negative sitting out in front. All right. Oops, and I goofed again. Boy, I'm making all sorts of mistakes in this problem. Negative 4 times negative 1 is a positive 4. Okay, so negative 1 plus 4 is 3. 3 plus 3 is 6. Take your 2 points to the right, mirror those to the left. And are we graphing this parabola with a solid line or a dashed line?
Solid.
Solid. Remember, it's solid because this is less than or equal to. The or equal to part makes it solid. All right, so now we got to pick a test point.
1, 1.
Sure, you can pick 1, 1. 1, 1 sitting right out here. Okay, if it was me, I would probably pick something a little farther away to make it more obvious whether or not I'm picking a point inside or outside the parabola. Okay, so I might pick something like 3, 0. Or maybe you could pick something even easier since you're doing all the math work, all the hard work with the x's. Pick something where x is 0. Pick something like, I don't know. Right down there. That'll be the point I pick. Let's see, 2, 4, 6, 8. So I'm going to test 0, negative 8. Because that's going to be super easy to plug in. Negative 8 is less than or equal to negative 0 squared minus 4 times 0 plus 3. So 0 plus 0 plus 3. That tells us that negative 8 is less than or equal to 3. Is that true? That is true. So my point was on the inside, so that makes this the true part. Outside here is the false part. Always shade the true part. Questions? Please remember, this is more of the same, right? Graphing parabolas using standard form or vertex form, depending on how they give it to you. And then deciding where to shade and deciding solid or dashed line. That's the exact same as we did, a week and a half ago now.
So it's just a different shape.
Exactly. That's the only difference, is now we're dealing with a different shape. Before we were dealing with lines and absolute values. Now we're dealing with parabolas. Okay?